Okay, well, as George mentioned, I'm Midair. I'm from Kyrgyzstan, but I live in Vienna nowadays. So if you're ever in Vienna, you can get in touch with me. Okay, so what are we doing in this talk? I'm going to demo a project, and I'm going to demo some tools, and hopefully we will learn something together at the end. So we're imagining that we have an online shop. We're a one-person data team in an online shop. It's not the biggest shop in the world, but it's a shop that has hundreds of customers, maybe thousands of customers all around the world. We have to ship orders every day. And we get a request from our bosses saying that we need to make predictions on the orders. So we need to be able to know if an order will be returned within 1 week. This is something they want to do for, I don't know, storage or something, I don't know. But they want to know if the order will be returned within 1 week. And for now, it's OK to do it in batches. So at the end of the day, we look at all the orders for the day, and we do a prediction. And but ideally, and we will get bonus points for this, is they want it to be live. So they want some kind of an API endpoint that they can call, and it will give you a prediction right away. And yeah, so that even before the user clicks order, they know that this order is likely to be returned or not. Yeah, so because we are in an automated shop, we need to build a pipeline that trains ML models and uses ML models. And ideally, it's an automated pipeline. So we don't want to, by hand, sit and train it every day. Ideally, we have an automated system that's training and then choosing models and then deploying them and using them. And everything is automated, so all we have to do is press a button and monitor from time to time. Which technology are we going to be using to build this MVP of this feature? We're going to be using dbt for transforming and cleaning the data. We're going to be using dbt for training ML models. dbt is going to be used to make predictions, and dbt is going to be used for automated deployment. So could you raise your hand if you know what dbt is? Okay, awesome. And could you raise your hand if you work with dbt at the moment? Awesome. Okay, so for you, it's going to be a little bit boring next 5 minutes, but I hope I clarify it. If I do something wrong, please tell me that what I'm saying is wrong. Okay, so in a traditional setup with a data infrastructure, we have ETL pipelines. We extract, transform, and load into our data warehouse. But nowadays, compute and storage are separated. So storage is super cheap, so we can just dump everything into our data warehouse. And this means that we can just load all the raw data from all of our data pipelines straight into our data warehouse. And then the challenge is we have to go from raw data to transformed data in order to be able to consume it in downstream when we do like machine learning, do reports, do dashboards. And so this is where dbt comes in. dbt is a tool that allows you to relatively easily define these transformations and productionize them and run them in a more or less reliable manner. Okay, so how does it work? So what is actually dbt? dbt comes with a project. It's a CLI tool, so you run dbt run, and it needs a project, which is the centralized structure of your transformations. Within the project, you'll have dbt models. Models are like tables or views inside a database. You'll have tests to make sure that the model is being generated properly and it can be done automatically. And then you have a DAG, because models can depend on other models. So you'll have like a DAG of models, going like, I want to run model A to B, and it will run it. What is a dbt model? The dbt model has to be a transformation. So when it's a SQL model, it has to be like a select statement. Yeah. So here, for example, we have a simple SQL model where we're doing some selection, and you notice that dbt supports Jinja. So here we have from ref model C. This is the dependency. So it shows that model D depends on model C. So before you compute model D, you have to compute model C. Okay, and dbt also supports Python models. And Python models, like SQL models, they have to define transformations. And in order to define transformation in dbt, it has to be a function. So you have to have a model function. It's definitely just called model. And here, inside the model function, you have to return a data frame. So that data frame is then going to be persisted as a table in your data warehouse. Okay, So, and here you see that this model has a dbt object that references model B. So model C depends on model B. And yeah, so not all the dbt, so dbt by itself is not a database, right? It's just a transformation tool. So you need to connect it to the database or data warehouse. And for Python models, not all the dbt databases support it. So Snowflake supports it, Databricks supports it, they both support it natively. BigQuery supports it kind of. You have to set up a dataproc cluster to run it. And if you know how to do it, that's awesome. If you don't, yeah, well, it's an adventure. DuckDB supports it, but you have to do it on your local machine. And then there's this thing called dbt-file. dbt-file is now our open source package. It's that we built. And what dbt-file allows you to do is allows you to do Python models on almost all adapters of dbt. So, but what we do is, like, when you just install dbt-file, it allows you to do the transformations locally on your computer. So not on the data warehouse, but on the computer. So what happens is that dbt-file downloads the data from the data warehouse, does a transformation, and then uploads it automatically to the data warehouse. Okay, so this is how we define a profiles YAML. This is a credentials file in the dbt project. And here you see we have a staging DB. These are the credentials to our staging database. It's a Postgres database that I have on my computer. And then there's another staging credential definition of type file. And this one is, we're basically telling dbt that we're going to use file with Postgres together. So file will do the Python transformations, and Postgres is going to do the SQL transformations. All right. So we have I have a test project. This is the project that I was talking about. We have a shop. We need to do some predictions on the orders, and we need to be able to persist those predictions in our data warehouse. This is what the GitHub repo looks like. So we have some requirements in order to set it up. This is dbt Postgres and dbt-file and Jupyter Notebook because we need to be training and predicting things. Okay, so this is our models directory. So inside a dbt project, you'll have to the code. This code? No, the QR. Oh, QR code. Sorry. It has to do animations now. There we go. Okay. I think there's one more person. Okay, awesome. Okay, so we have a models directory. So this is where we actually define the transformations. And as you can see, we have 4 models here. And don't worry about the bottom 2. These are what we're actually building here. But the top 2 are the models that are already in our data warehouse. So this is something that either we or somebody else already made. And we have customer orders model and customer orders labeled model. So as you might guess, customer orders labeled is a table that has customer orders labeled with whether or not they were returned within 7 days. And then customer orders doesn't have that label. Okay, so now dbt, as I said, comes with a CLI. So all I have to do to actually run a calculation on these SQL models is I do dbt run. I tell with profiles deal where my credentials are. And with select statement, I'm telling which models to do the calculation on. And so now dbt talks to Postgres. It's a Python package, but it talks to Postgres, and it runs the models in the order that it knows from the references. Okay, so now we go into a Jupyter Notebook. This is the same project. I just opened a Jupyter Notebook in this project. And here, I'm opening a notebook. And here we have this from file import dbt-file. So this is, again, it comes from us. This comes from the dbt-file package. This is an unofficial dbt Python SDK. Yeah? So you can create this file dbt object and tell it where the credentials and where the project directory is. And once you've done this, this means that now this file dbt object is now aware of your entire dbt project context. Yeah? So what this means now is that you can actually download your dbt tables as data frames into your Python runtime. So here, for example, I'm getting a customer orders labeled table, and you see I have a data frame and I have a return column is 1 or 0, and it's telling us whether or not the order was returned within 7 days. It's just a data frame. I can look at the statistics of the data frame just to see what the distribution is, how many different things there are. This is completely generated data, so might show some AI bias, so don't judge. But so this is the data that we have. We have total price and we have age, and the red dots are the dots that were the orders that were returned, and the blue dots are the orders that were not returned. And as you can see, there's some correlation between price and age, where when a customer is younger and the price is higher, the orders tend to be returned more often. So this is a very simple logistic regression that you can train that would be able to give you the prediction. And so we can do it straight in the notebook, of course, because we're in a Python runtime. And so here I'm just getting a simple logistic regression, and I am instantiating it, and I'm training a model with it, and then I'm looking at the classification report, so seeing how good that model was. Yeah, and it's just in these lines you can train a simple ML model, and we have an accuracy here. You say accuracy line, it says 0.84. This is 84% accuracy for this model for the given data. So at this point, I would go to my boss and be like, hey, is 84% good enough? And they would be like, it's better than 60, and you can go ahead and keep implementing MVP. Yes? This is the kind of thing that you can improve over time. I think for me what's important most of the time is to get the MVP out so that we have something to improve. Okay, so now that we have that, now let's put it in actual dbt so that it can run automatically with a dbt run, right? So I have a model here, and in the model I'm calling this function called train ML model. So this is now the function that I defined in my notebook. I just have to port it into a Python file, which is a dbt model. Yeah, so this is the train ML model function, and you see here it takes a features data frame and a labels data frame and does exactly the same thing that we were doing in a notebook, except now the model that we trained with scikit-learn, we get some metadata off of it, and we store that metadata in our dbt table so that it's persisted in our data warehouse. We can come back to it whenever we want. We also store model weights, so we tell it the location where to store model weights. We create a pickle file and we store it, here, ML models home directory. We just put it there, and our model weights are now persisted. So now we have a mapping between, our model metadata and our model weights. Okay, so we can just run this. I think. Yeah, first we tell it where to store the models, and then we run our dbt model, and it runs, and it does a quick model fitting, and it's done. So this means that now in the ML models directory, I have a pickle file, d48. This is now the model that I just trained. And so now that I have a model, I have to make a prediction and then store the prediction in a data warehouse. First, I do some experimentation. I go back to my notebook, and here I now open the table customer orders that does not have a label. So this is a raw data that is not labeled. We don't know if the orders are going to be returned or not. And so now my objective is to make a prediction with our model. So here, this is now a dbt table that you see. It has a model named D48. So this is the model that I just trained, and I just put in the pickle. I mean, I trained it in April because I prepared this presentation in April, but it's okay. Yeah, and so now I write a little Python, couple of lines just to say, okay, pick the model with highest accuracy, load it from the local storage, and then run a prediction by using that loaded model. And here we do a prediction, and then this orders new DF sample will be the sample of our data frame that now contains our predictions. And now we see that we have a predicted return column that has zeros or ones. And we can go ahead and try to do a plot of it. So it's plotted, and it looks about right. So the colored dots are approximately in the right place where they're supposed to be. So with this, we could be happy enough to now put it in a dbt model so that, again, it can run automatically. And this is it. This is the model definition. As you can see, we have two functions here. The model, this is a dbt-specific function that tells the dbt to run the transformation. And all it does, it calls make prediction function. And in the make prediction function, we're doing the same thing we did in the notebook. We're just finding the best model, opening the pickled model definition, and then model weights, and then running the prediction on the dbt table. And so now we run dbt on this. So it's running the Python. It did the fitting, and it saved the result. So now I have a new table called order return predictions. And so now this is a dbt table that's now in our data warehouse, and now we have our predicted returns there. Okay, now this means that I can now run, no, hold on. Okay, so now there's a problem in that the dbt file runs Python models on our local computer, right? And I cannot deploy my local computer to run the dbt models for the company, so I have to put them somewhere. And one of the places, so you can put it anywhere. You can put it on GitHub Action, you can put it in Docker, like DigitalOcean or whatever. But we have a file serverless offering. This is a project that we have. It's a project that we have. And what it allows you to do is it lets you import this decorator called isolated. And when you decorate a function with this isolated decorator, it now runs on a serverless platform that is file serverless. So this is our platform. You can set it the requirements. You can set it the machine type. And what it does is that when it runs the function, it cold starts a machine. It cold starts a process. It installs the requirements if it needs to install them. And then it runs it, and then it kills the machine. So I'm doing the same thing here for this other model. And now this means that when these models are calculated, now they can be run on a GPU machine. Like you can control the machine size, so you can run it on a GPU machine, or you can run it on an extra large machine, depending on how much data and how much training you have to do. Yeah, so now with those defined, I now have to tell where to store the weights, because serverless now stores weights in a serverless directory. This is a persistent directory, and so now I can just do dbt run. And this is the training. So now, like I said, it takes a bit more time because it needs to start the machine. It needs to run the thing. Here it did it, and then it needs to turn off the machine. Now we do, so that was training. Now we do the predictions, and we're doing the same thing. So again, it takes a little bit of time, because depending on the requirements, if requirements are different, it will be a different process that will start. And now that's done, and we can be happy. So this means that now, in order to test, we can test everything end to end. So if I remove all the select statements, now it runs the SQL tables and Python tables all together in the correct DAG. And so we have the end-to-end solution. We did the training, and we did the prediction. Okay, so now it's time. Now I have an end-to-end pipeline. It's time to deploy it somewhere so that it runs regularly without me having to press a button. And for this, my favorite tool is actually GitHub Actions. And in GitHub Actions, first, of course, I need to set the credentials, right? So it's not going to be on a Postgres database that I'm running locally. So we have a Redshift cluster from AWS. And this is where we store our production data. So we have dbt-file and dbt Redshift adapters. And in our credentials, we have to make sure that we have production credentials as well that now have the credentials from Redshift. And with that set, we can actually define a GitHub action. We just have to create this .github workflows directory. And there you can define a YAML file. In the YAML file, I'm just saying on which conditions this YAML file should be executed. And so here we have pull requests, or like a cron schedule, or workflow dispatch is actually pressing a button. And then what happens when this job starts is that now GitHub is starting a machine and running the process. And what GitHub does here is that it starts a a machine, and it basically runs dbt. And you see at the bottom there, we have dbt run. We tell it where the profile is, and then we tell run with target production so that it writes to our production database. Okay, so now once this runs, we're done. We have a batch level ML pipeline that A, trains ML models, B, selects the best model out of the trained models, and then does predictions on the best model. But as I mentioned, our bosses actually want something extra. They want live predictions, right? And this is something that you can actually do with file serverless as well. But first, how would you even do a live prediction? So in order to do a live prediction, you have to get one row, right? You have to get a single row with a single, the column values. And we create a fake data frame out of it just so that we can give it to the model, and then the model does a prediction, and then we return whether or not the prediction will be positive or negative. And here we test this predict return function. We give it different values, and it predicts either true or false. This is now our ML model doing those predictions. And so we have this web endpoints directory here. So what it has is this simple Python file where we basically have the same function. So we have some environment variables where we tell which model to use and where to find the model. And then the function itself does the same thing. It just opens a pickle. It takes age and total price as arguments. And then it opens a pickled model, waits, and then does a prediction, and then returns this dictionary saying prediction, and this is my value, 0 or 1. All right. Okay, so our file serverless package comes with a CLI tool. So first I tell it where to find the models and which model to use. And now, as you can see, we have this command called file serverless function serve. We tell it which file to serve and which function to serve. So will return is the function name, and I give it an alias so that I remember what this function actually does. And when I call this, it gives me a URL. This is a URL of that function that's now an app that's a cold startable app. Yeah? So this means that I can do a curl to it, and when I do a curl, what it does, it starts the machine. It will install the requirements if it needs to install the requirements, and then it will just return the result. So here, yeah, you have to set some credentials, and I'm passing a simple JSON that has age and total price as keys and values. And yeah, so now I started running it, and it returns result prediction 0. So I can try it again now. Now it should be faster because the machine is already started. So maybe it's still not off yet. So it's prediction 0. So I change the value, and now it's prediction 1. So now we have a web endpoint that we can call that loads the model that we told it to, and now it can return us the results, predictions live. Now we can give it to a front-end engineer, and they can just call this endpoint and get the information they need. All right, so in summary, we have a dbt pipeline that trains models. We have a dbt pipeline that predicts batch data. We have an automated workflow that runs the whole batch process. We can serve ML models via API. And everything is in a single dbt project. This is a single repository. Now you don't have to run around in different places figuring out what's doing what. Everything is in one place. All right, so I'm Midair. I'm from Features and Labels. We're a company focusing right now on serverless Python, and I'm very happy to be here. This is our team. If you have any questions about file serverless or about dbt or about anything else, don't hesitate to find me. And thank you for your attention.
Thank you, Midair, for your talk. It was great. If you have any questions, you can use the microphones. We have almost 5 minutes, so I will.
Sorry, quick and unrelated question right here. I'm here.
Oh, hi.
The mouse cursor was moving while you were talking. What black magic was that? Is there someone else controlling while you were?
Yeah, I have a slave.
Okay.
No. It's a recording.
Oh, okay.
Yeah. That's why it said it was in March. I mean, in June. Yeah.
It was very good.
Thank you.
Thank you for your talk. Just wanted to ask, do I need to always return only pandas data frame, or can I use something else instead of pandas?
That's a good question. So for dbt-file, it has to be a pandas data frame right now. Yeah, but it depends. Like, why? Are you asking about the different?
Yeah, so I can perform transformations, I don't know, using polars or something like that.
Yeah, I mean, the model has to return a data frame in the end. So yeah, that's the requirement right now.
Yeah, so it can be like polars the data frame or Spark data frame.
I think so. I think
okay.
So. Yeah.
Thank you.
Thanks very much for the talk. One question, do you support the entire machine learning model lifecycle, such as monitoring data drift or model shift, or also how do you have like a model registry in your solution?
We do, yes. We have a model registry and we have models that can detect that, but we also provide you a platform to make it easy for you to deploy them, right? So if you have a model in mind that you want to use, and it's pickable and it's loadable onto our serverless platform, it will run without an issue.
And for example, in the GitHub Actions pipeline you showed, like, is there any way to ensure that if a model doesn't reach a certain accuracy, that it won't run in production, so it gets cancelled, for example?
Yeah, so this is something that dbt can handle on its own. So for example, if a parent model fails, no children are going to be executed. Is that the question?
Yeah, kind of. Well, if the training stage does not reach like a certain threshold, and you want to like cancel the entire pipe.
Yeah. So you can fail the training model, and the children models will not work in that case. Yeah.
Any more questions? I don't see anyone. You can find Medel outside to ask more questions if you want, or in Discord. Thank you again. Great talk.
Thank you.